Hello, and welcome back to a brief tour of LIDA. I'm Steve Strain, a researcher from the CCRG at the University of Memphis. In our last video, we introduced Franklin and Gracer's 1997 definition of an autonomous agent, which forms the basis for LIDA's definition of mind simply as the control structure or set of mechanisms and processes that determines the behavior of such an agent. It bears pointing out that by its emphasis on behavior, this definition anchors our concept of mind firmly within the realm of observable phenomena, a key requirement for any scientific approach. Next, we'll look at the LIDA model's fundamental goals and the methodology by which it applies this working definition of mind to the pursuit of these goals. So, what does the LIDA model hope to accomplish? First, we'd like our model to accommodate as much as possible of the knowledge gleaned by the various disciplines mentioned in our first video: philosophy, biology, psychology, neuroscience, and computer science, as well as any other field that might help us understand minds. But integrating across so many fields is not going to be easy, since, as already mentioned, there is no consensus between or even within fields on what mind is, and quite a lot of controversy. So we can be sure that we'll need to make some tentative commitments at the beginning of our work that may prove incorrect later on. More on this in a moment. Having defined the mind as a control structure of an autonomous agent, we need to be able to understand how such structures are put together. So we'd like to depict the organization or structure of an autonomous agent's mind. In a future tour, we'll explore something called the LIDA diagram, which is essentially a highly detailed visual description of a generic mind's structure. We'll also need a language with which to describe mental processes, that is, processes that determine the behavior of agents. In addition to depicting mental structure, the LIDA diagram will also provide us with the elements of such a language. We want our LIDA model to enable us to understand biological minds well enough that we can accurately and effectively simulate them, meaning that our simulations should make decisions as well as and in the same way as their biological exemplars. We also hope that LIDA will allow us to design and implement artificial minds that can make decisions and solve problems in ways similar to biological minds. With these goals at the forefront, we take the following approach to investigating minds. For any given behavior in an autonomous agent, we can use the LIDA model to create a proposed narrative of how the control of that behavior is accomplished. We then use that narrative as a guide or template for writing software to carry out that control. If the particular autonomous agent under study is a biological agent, our software implementation will represent one or more hypotheses about how that organism's mind works, and the results of executing that software will constitute an experiment to test those hypotheses. In the case of an artificial agent, the purpose of the software will be to replicate or adapt biological or human-like mental strategies for a technological purpose. We call these two complementary approaches the science fork and the engineering fork, respectively. Agent implementations along the science fork seek to answer basic questions about how known biological minds function, while those along the engineering fork seek to apply our understanding to the development of technological solutions to real-world problems. A key philosophical idea in LIDA's approach is that successful technology developed from a scientific model or theory provides at least circumstantial support for that model or theory. A moment ago, I mentioned the idea of tentative commitments, which may need to be revised as our research moves forward. A complete coverage of this topic is beyond the scope of a short video, but it illustrates a Darwinian aspect of the way in which the LIDA model has evolved over time. Even so, there are some concepts at what might be described as the genetic core of the LIDA model. In our next video, we'll discuss two of the most important concepts in the LIDA model. The first, the cognitive cycle, was mentioned briefly in the second video, where we promised to say more about cognitive cycles soon. If this made you curious, stay tuned. The second concept addresses the observation that at least some biological autonomous agents are conscious. So if LIDA is to be a complete theory of mind, it has to tackle this question in some way. However, as we'll soon see, consciousness is such a big subject that it's not entirely clear who has tackled whom. Thanks for listening. Hopefully we've made you curious to learn more about LIDA. Please come again and see you in the next video.